All right, let's get going here. Hey, everybody, thanks for joining today. This is Mark Schultz with DigitalAircraft, and we're really excited about bringing this educational series video to you today. And it's on aviation, it's on blockchain within Aviation Decoded. And we have a couple of guests here today with Ewings. We have Michael Shea, the Chief Operations Officer, and Michael has more than 30 years of experience in the technology sector. He has global consulting services experience. He's founded multiple businesses and is currently advising startups as well as actively working on a blockchain startup in London. Michael holds a mechanical engineering degree and a master's of engineering and an MBA in innovation and entrepreneurship. Michael, thanks for being with us today.
Thank you, Mark.
Excellent. We also have Stefan Fosa. He's the CEO of Ewings and also the founder. Stefan has more than 30 years of experience in the aviation industry, working 13 years with the Austrian Air Force as a lead technician, so he has maintenance experience. And after his career in the Air Force, he joined civil aviation, founded in 2009 his own camel consultancy business, so he understands maintenance programs in the commercial industry, and supports several aircraft operators and owners throughout operations, acquisitions, and sales kind of activities. During his career, he gained in-depth knowledge and experience in dealing with various legal systems and regulations around the world, and motivated to transform the industry and get off of paper-based processes into a real seamless digital world. He founded Ewings in 2017. Hey, Stefan, thanks for joining us as well.
Thanks, Mark. Thanks for the introduction. I have nothing to say.
Excellent. Okay, well, very good. Well, listen, we're really excited to bring you this educational series today. And we're going to turn this right over to Stefan and to Michael, and they're going to walk us through this webinar today. Gentlemen, you can feel free to take over.
Thanks again, Mark, for your lovely introduction and the opportunity today to speak to you all about blockchain, aviation, digital identity. What we are about today, we're going to do is one of the challenges that we've found as we've talked with different customers is what does blockchain mean, and the level of knowledge and understanding within the industry around the jargon and terminology. We know from that there's a widely variant. Generally, most people have heard of some of the terminology, but really don't have a strong depth in it. So part of today's conversation is really to give you a baseline of what blockchain is, where does it make sense, some of the elements then that are coming and that have been enabled and that will be critical, we believe, within the aviation sector. And then going into covering more details, digging more deeply specifically into the MRO space. So blockchain. First part of the blockchain world is the difference in the architecture. We're familiar, everyone is familiar with the nature of a centralized architecture. That's the internet as we know today. That's the, Amazon, Facebook, Google, or really any site where you have sort of a authentication credential. We as individuals go to different websites, and that's that sort of centralized architecture. Over time, there is decentralized is slightly different. It breaks down that level of criticality in a node, if you will. Somewhat similar nature would be, some sort of the hub and spoke system of the United States in the aviation space, so where you have large airports that are then feeding in different areas. The world of blockchain changes the network architecture one further space into a distributed peer-to-peer network. What's different is the nature of the peer-to-peer. Peer-to-peer is not new. Anybody who is familiar with things like BitTorrent and other sort of sharing services, it has been around for quite a long time. and this is actually a key piece within the blockchain space. A lot of the initial technology that came in with Bitcoin and blockchain actually wasn't new technology. It was technology that the newness of Bitcoin and blockchain was how the technology was packaged. Peer-to-peer networks have been around for 10 plus years. Some of the cryptography, the hashing algorithms, jargon here being called SHA-256 has been around for years. So all of this stuff, it really has become, what's unique is how it's been packaged together. So in a distributed ledger, which is what Bitcoin, Ethereum, Hyperledger, these are all, and by far the largest majority of the different blockchain technologies, there are other ledgers out there, are this peer-to-peer distributed ledger. Within the distributed ledger, they break down more or less into two major categories. Ledgers where where you are anonymous, really what would be called otherwise a permissionless system, and those which are permissioned, or AKA not anonymous. Now, I will disagree a little bit here with this slide from Block Geeks, where I stole this image from, but you are not anonymous on a blockchain, all right? There's only two of the different cryptocurrencies, which would be Monero and Zcash, that have some degree, that are come close to true anonymity. Blockchains are pseudonymous, which means you have a public key, but it is absolutely possible to reverse engineer who that public key belongs to. So it's a little bit of a misnomer here. That being said, the difference between a permissioned and a permissionless is really just that. Bitcoin is a permissionless system. Anybody can write a transaction up to the blockchain. There is a whole consensus algorithm. Consensus here is how the network deals with the what's otherwise called double spend, but really it's how it maintains the integrity, the blockchain integrity, data integrity across the network. In Bitcoin, well, I'll go into the different consensus algorithms in a minute, but this is really the main difference between a permissioned and a permissionless system. A permission system is just that. It's a system where to participate, you must be known, or particularly to write transactions or to approve transactions on the blockchain, you must be known. These are both perfectly valid. It's not that one is better or worse than the other. It really depends on the business conditions and business rationale as to which makes most sense. So moving on to the different technologies, as I mentioned earlier, there are many different blockchain networks out there. By far the largest three are Bitcoin, Ethereum, and Hyperledger. Bitcoin is the first. It is created by the mysterious Satoshi Nakamoto off of the famous white paper from 2009. It came into existence, I think it launched in 2011, and has been around now, actually no, it's been around for 10 years now. So it went live in, I think, in 2011. So it is the granddaddy. It uses a consensus algorithm called proof of work, which is based off of raw computing power, or what they call hash power. And this is why there is a lot of negative press around Bitcoin, just around the amount of energy that is required, because it's a computationally intensive algorithm that requires significant electricity in order to come to consensus. Ethereum is a derivative. Originally, the blockchain came from the Bitcoin blockchain. It is significantly different. It is still currently using proof of work as its consensus algorithm, but it is in the process of shifting over to what's called proof of stake. And probably the main difference, or the most significant difference between Ethereum and Bitcoin, is this concept of a smart contract, or a piece of executable code that is actually resident on the block, on the Ethereum chain. This allows for what they call distributed applications, allows you to put code and create systems that actually reside on the blockchain. Hyperledger was originally created by IBM, and it is a derivative of Ethereum. The main difference of Hyperledger compared to Ethereum is Hyperledger is then what you would call a permission chain. It is used particularly with industry, within industry groups, where they are creating an ecosystem for very specific industry groups. An example of a Hyperledger permission chain, which is in production, and it makes absolute sense as to why it is a permission chain, is a blockchain put out by an industry association called ISDA, that's in the financial derivatives market. It is only eligible, you can only participate if you're one of the 600 financial institutions that are part of ISDA. It makes no sense to have it a public chain. So this is where it's really important when you start to consider, or you're talking with people about different blockchain technology, to understand what is the business environment that you're operating in. If it is, do you need a public chain? Is a public chain actually advantageous? In many industry-related chains, that's a hard question to sometimes ask. There may not really be a hard, good reason for it to be a public chain. Now, there's a couple other different technologies that are out there that are worth mentioning, because particularly in the industry and the IoT space, you may hear of it. One is IOTA. IOTA is another chain. It's been around for a good while as well. It doesn't use a chain, actually. It uses what's called a tangle, or a directed acyclic graph. It's a different structure, and it's, again, engineered specifically for the IoT space. There is another project which uses a construct called a distributed hash table. And these are all, this is holochain for those that might be aware of it. These are all different technologies. They're all trying to prove this decentralized distributed architecture. And this is what we're, it's an evolutionary process to see which one will be the survivors. So one of the things that we have run into in our conversations is, well, what do I store? Do I store personal information? Do I store part information? What do I store on blockchain? Or I'm going to store this on blockchain. This is a bit of it causes a lot of confusion. Storing on chain is actually a very expensive solution. This graphic here is resulted from the IPDB Foundation, and I don't remember the exact date that this graphic was created, but it's essentially representative. To store on chain costs a lot of money. So looking at Ethereum, this makes sense based on the relative price of Ether compared to Bitcoin. $5 million to store a gigabyte of storage on chain. If there's no other reason, that's a pretty good hard business reason as to why you don't actually want to put a whole lot of information or particularly large amounts of information directly on chain. You want to use it as a reference to where it's stored off chain. The other part is the number of transactions. The actual transaction size on either both Ethereum or Bitcoin is actually quite small, so you end up fragmenting the information and creating thousands of transactions, which then drives the price of cost of storage. So the on-chain storage other challenge around on-chain storage is even if encrypted, if there's anything that comes in particularly with personally identifiable information, is considered extremely poor practice. Encryption will be broken, and once written on chain, it's there forever. The chains are immutable. This is one of the key value propositions of the blockchain, is that they don't change. Once you write them, they're there forever. Off-chain storage is somewhat similar to how an old or how a hard drive works, or a solid-state drive works in your computer. The information is actually being stored. You're storing a reference on chain, which is then can be dealt with and used to access where the actual storage is off chain. This makes the whole operation a whole lot more efficient. It allows aggregation of data into manners to reduce the number of transactions you're putting actually on chain, reduces your operating and your overall operations cost. So this is really where one of the points of great confusion when we talk with people, we've been talking with people within the space. So blockchain, one of the other things to think of, what does blockchain actually bring? A blockchain is creating a community. It's creating a community of where you need to share information or really share information across participants of a ecosystem. When we look at the aviation industry from as a whole, we see at least 5 major ecosystems, and certainly we could be convinced that there's more. First is the maintenance, repair, and overhaul. Then there's passenger. Then there's cargo, airspace management, so the tracking of flight plans, and then airport management, baggage, and ground operations. All of these are really ecosystems unto themselves. What's key to remember, and this is where, if somebody says to you, well, why do I need a blockchain, or where should I use a blockchain? A good rule of thumb is, do you have disparate organizations that actually need to work and share information between them? So if we take the MRO space, based on our analysis, there are approximately 7 or 8 roles of stakeholder roles participating in the MRO sector. That being the lessor, the operator of the aircraft, the manufacturer, the 3 or 4 tiers of suppliers from your tier 1 to your tier 4 supplier, the MRO, and the regulator. All of these organizations need access to the airworthiness documentation around the maintenance and operations of aircraft. Right now, that's all done on paper, so that makes it very difficult. So this is an ecosystem. This is a closed, effectively from what our perspective is, a closed ecosystem. It's a large ecosystem, but if you're building cars or you're fishing, you don't really need to have access to what's going on in the aviation maintenance ecosystem. So this is how we define it, and I think this is where it makes sense, where a blockchain actually makes sense, because you have information that otherwise is very difficult to share. Within the blockchain world, it becomes much, much simpler. So what dimension cuts across all 5 spaces is identity. Identity in a digital form impacts all of these. The identity has 3 major dimensions: that of an organization, that of an individual and that of a thing. So if we look here at these 5 spaces, certainly the MRO covers all 3 dimensions. Passenger, that's pretty obvious. Cargo, again, you have the carrier, you have the shipper, you have the person who's actually put the parcel, given the parcel to the shipper or the organization. So you have, again, all of these identities, all of these things, identity cuts across. This is one of the things that in our conversations that, particularly when you talk about supply chains and part provenance, everyone talks about the identity of the part, but we really haven't heard anyone talking about specifically the identity of the technician and the certification levels that the technician may have in the MRO space, and the identity of the organization that's actually doing the work, and whether that organization is certified, and who are they certified by, and what are they certified to do, what operations are they certified to do. In the digital identity space, all of these things now are able to be create digital credentials, what's called verifiable credentials, which allow the tracking and the usage of the credential that then becomes part of the relevant information around the maintenance of the aircraft. So now not only do you have the part provenance, you now actually start to move up the value chain and look to free up people that way. So one final slide here on identity, and then I'll pass it off to Stefan, and we will get into the more meat of the MRO. When we start to write the data, again, with the provenance of the part, in the maintenance space, it's not just the part, right? So yes, the heritage of the part and where it came from and which tier supplier and the certificate of airworthiness, all of that's very important. But it is the whole picture. It's not just the part, it is the technician. It's not just the technician, it's the organization, and then the operator. So all of this information needs to start then becoming part of the whole digital record, the digital heritage of the maintenance operation and of the aircraft. So the way we are looking at it, the way we are working within the Ewings world is to create, we have that initial cryptographically secured fingerprint, if you will, with the IP that did. That's what this, the technical jargon here. But then we start to attach multiple layers of metadata information around that one part. It's not encoding all that information on the tag that sits on the part that may be attached to the part. It's using that tag and that cryptographic signature as a reference or a hash that then it brings it into where we can put a lot more data within the metadata service. This is something new within the aviation space, but is not new in other industries. Using this type of a reference really to allow you to attach a significant volume of data without having to try and squish all that information into a single tag on a part. So I'll now hand it over to Stefan, who will then go into the MRO.
Wonderful. Thanks, Mike, for the very good warm-up round. Also, thanks, Mark, for the introduction. So I will not add much information towards. So we all know the issues in the MRO world, and it looks like that. Being myself more than 30 years in the MRO space, operator space, having done I don't know how many aircraft transitions from operator A to operator B, reviewing physically the airplane, taking it new from the OEM, putting data into systems. Yeah, I have learned my lessons hard, and I've thought always over the years, how can we improve, and starting with file systems and all that stuff, but it never really ended up because it was always more an application. Something was missing, a missing piece, and I think now with blockchain technology, this can enable and will enable the way how we do things better, because we know the problems in terms of too much paper creates a lack of transparency, and lack of transparency brings lack of traceability. And so are associated a ton of money in terms of finding and searching data instead of using it the right way in terms of creating them right in front out of our systems in a digital manner so that we can reuse the data in a standardized format. So that created then our vision. So we founded Ewings to build a cost-effective data sharing ecosystem using standardized data, either throughout the whole value chain. So either coming from standards already existing, like the ATA Spec 2000, and or other industry standards in combination. But I will come later towards that. So in order to create an environment Michael described briefly previously, you need to secure the endpoints. So that's very key, I think, and that differs us in terms of other thought leaders out there. Because it's important, because we are shifting from a lock-in password paradigm environment we all know towards a distributed PKI infrastructure. And therefore, whilst creating all the key pairs, when you do the logging into a system, authenticating yourself, you're using PKI technology in the background. So, and therefore, to have a very secure environment, and then in a distributed manner as well, the endpoints, which are represented by, let's say, an operator, lessor, or whoever we can think of, running a blockchain node, needs to be secured, because we want to know who runs and who operates the node, so then we have a trusted environment created. And when you look at this picture here right now, behind the thumb, there's a little board standing up vertically on the printed circuit board. And this little board here holds a secure device. These are key elements in terms of building a secure environment. So this creates then a completely different setup in terms of the way how we do things currently. So what we want to show with that slide here is track and trace throughout the value chain when using secure identifiers, part identifiers, in form of a crypto-enabled UHF RFID tag. Imagine the tier 1, the tier 2, 3, and 4s. They have their contracts with OEMs and tier 1s. And based on that, they will produce parts, and they need then to add information to the parts they're producing. So they will generate in future a digital fingerprint for that, or not a fingerprint, a digital certificate for the part they're producing, which they then ship towards the tier 1 supplier, for example. So let's catch this out a little bit here. So this represents here now a digital certificate, or digital certificates. And the digital certificate is getting a fingerprint, we call it hash, and this hash is then stored in the blockchain. You see this in the little block. And the metadata from the certificate himself, you know, everything that what we normally rely on, is then stored in a distributed metadata storage. And what means distributed metadata storage is we have a diverse possibility in terms of where we store those metadata. So it could be either running in-house from yourself. It could be, you know, hosted by a third-party provider. It could be hosted with a consortium of 20 organizations from the industry. So it creates a lot of freedom at the end of the day, and so nobody really owns the network underlying. Not to compare, not to miss out, you still own the data, because you have an access key in terms of cryptography. So who owns the data owns the key to unlock the access. So let's so there is an interconnection between the hash and the metadata. So they are interlinked. Otherwise, you will not find the hash and the metadata associated together. So then you ship all the parts towards the tier one. The tier one receives the part in his logistics department, and he scans the UHF RFID tags associated and attached to the part, or to the raw materials, whatever, you know. And then based on cryptographic credentials, previously described by Michael, he then can verify the first time what we could not do before. Okay, it came from the right source. And the company producing that part was allowed to do it because it had a verifiable claim associated from the National Aviation Authority, for example. And the person signing for the company is also approved because it has a verifiable claim from the organization it worked with. So you can tick all the tick boxes, and it's getting then really, really fun, this technology, when you then can connect other standards, like, you know, for shipping labels. So you can stick the same technology of what we're using for the secure part identifier, you can use on the shipping label. And then you can enable payment systems. So things are getting more and more out into a highly automation when you use that technology and combine them, for example, the GS1 standard for the labeling for shipments. The reason why I'm mentioning this is because the World Trading Organization and the World Customs Organization are asking more and more for having GS1 standards, which is coming from this full supply chain, you know, is one of the biggest standard bodies in the world. More than 150 countries are participating. This is a non-for-profit organization and generating an enormous amount of standards, where even we from the aviation industry participate with as well in terms of how the ATA standard, Spec 2000 standard was specified for the UHF RFID tag. So we're using that standard kind of as well. So just finish the tier one right now. So he builds then, based on all these certificates he gets collected in his incoming receiving, he builds his parts. So he's then, when it's done, testing is done of the part, whatever he needs to do, that he can issue a certificate. He is creating this unique identifier. And he sticks it on the part, and he links automatically all associated metadata towards what we described previously. And then, boom, he sends it off to the life cycle and hands it over to the OEM, and then it runs through, you know, 30 plus years of its life, and that's the way how it can look like. So the OEM installs it, the MRO afterwards may remove the part, ships it around, you know. You can also link to the digital twin then thereafter all the shipping data, so that you can always see, okay, it was always within the environment where we want to have it, to have full track and trace. And that in a very simple manner, actually, just enabled by some simple tags at the end of the day. So why UHF RFID tags? We didn't not really invent that, so that what we may make new is the way how we use cryptography on the tag. So this is a specialty what we have developed with our partners to make the tag very, very secure at the end of the day. But you will not recognize it whilst using it. You just can trust that it's very secure, because everything happens in milliseconds when you print the tag. So you even don't recognize that there is high sophisticated cryptography running in the background when doing that. Here's another example using blockchain technology. Michael previously already started to outline that, but I want to give you a little bit of a visual impression, because pictures speak more than 1,000 words. My grandma told me. So here are all the stakeholders on top of it, and imagine we do an aircraft registration right now. The aircraft is new. It can be used as well. It doesn't matter at the end of the day. But what happens? Let's see that the lessor owns the aircraft, and then he is using some new system from the AWG group, the CET system will be developed. And when all the contracting between the lessor and the operator is done and finished, so what happens in the background? Because now we have digital data. And on the top of it, you want to hand over the key previously mentioned, the access key. So you hand over in a transmission declaration with a certain process, you hand over the key from the lessor to the operator. So he can then access all the data afterwards from the aircraft, what represents the value and the asset of the aircraft as we know them right now in terms of modification lists, in terms of the life limited part lists and other lists you will see later on when I click to the next page, which we are all familiar with in the aviation industry. So what you see here in the picture is you have the delivery data in the middle from the OEM, and then over the time on top of it, you add new modifications, because that's the way how we work since years in the industry. We add service bulletins towards the aircraft because it's aging and we need to bring up the standard to keep the type certificate alive. We exchange parts and we interact with ERP systems. We interact with publications. And for example, when you register the aircraft, so then you can share the information with a graphical user interface, of course. We're just talking here right now about metadata and things like that in the background, sitting in a diverse universe of a distributed metadata base, secured with a blockchain layer or with blockchain layers at the end of the day. And because these are, it's just code, you can't read it as a normal end user, so therefore we need to have applications sitting on top of that ecosystem. We call it also railway. Michael defined this when we talked about all the stuff. So then the National Aviation Authority can access the data, and it's very fast and for them, because to verify and see, okay, this is all there. What we normally do in a paperwork review, so that then goes up to a few minutes or maybe half an hour to go through and see, okay, the aircraft. So these are the capabilities and possibilities what the aircraft is capable of, so that the operator can do the right applications to get the right certificates back from the authority. And then in future, when you do the whole process, you have also embedded automatically the MRO system, even if they're working on a different ERP system, it doesn't matter at all, because they're connected to the background, to the back end, to the railway, so and to the access to access the data, and so when the MRO is ready for example, with his tasks, he gets the operator asked him to do, then the NAA can issue the certificates in a digital manner and link them as well to a secure identifier. That might not be a UHF tag, it can be an NFC tag, it doesn't matter at the end of the day. So this gives us really, really new possibilities. So we can link manuals towards that in terms of storing the data in a distributed database and accessing them via shop function, for example, where the shop is hosted and held by a community of the industry, together with the OEMs. And then you can link with APIs your ERP systems, that you can then have all the tasks from all the job cards, getting the data from that ocean in the backend on data. So here actually you see when it happens, when maintenance happens over the lifetime, because the aircraft is flying, it's collecting hours and cycles. So you need to regularly, based on the maintenance program you have created and approved by the authority, you then, the operator makes his package, what he needs to do, and then he's handing this over, to the MRO. And here comes then, the magic thing, because when you link this with publication data, then, and with the previously shown other data from the aircraft in terms of the aircraft, I'm pre-modification, I'm post-modification, then the MRO knows automatically on what configuration the aircraft is, for example. So you bring the possibility to technicians so they have automatically serialized manuals in future. So that's really, really powerful, because we're wasting so much time in terms of asking, are you that and that modification, when we do all the maintenance events organization. So that gives a round picture. And for when we track and trace the utilization of the aircraft in terms of logbooks on paper, where the pilot is writing in and how often not making pilots faults after an 8-hour, 9 or 14 hours flight, because they think already on something different. So, and now using the EFBs, the electronic flight books out there. So, and the industry is already working on standards in terms of get the data in a standardized format out, so we can use that already. And then we timestamp everything, collect everything digital, and then when a part or maintenance event happens or a part replacement happens, then this is documented with the latest and greatest timestamp of the aircraft, for example, which is very important for us. And then this adds towards the digital twin previously shown in the same format as we already know it. But then everything is linked always to parts and to an aircraft. So this was it from my side so far. If you have questions, please post them, and Mark will review it afterwards. And now, Michael, please do the recap.
So just to recap, basically what we've talked about today. We've covered three main areas. One is blockchain and the commons, going over where, basics of what blockchain technology is, why and where blockchains make sense, the idea of a commons or an area where industry participants want to work or need to work together to optimize business operations. Talked about digital identity, how identity is a key element in the digitalization journey within not just aviation, within many industries. And what the value that will bring to free technicians, to free people to be back and doing what they actually need to be doing versus dealing with paperwork. And the MRO, and Stefan covered a lot of the areas where we believe, both from experiential knowledge and our initial forays and work in this space, as to where the significant value will be added to the industry. So it's change. Change is hard. So why bother? It really is, there's a lot of elements that are factoring in here. Focusing specifically on the MRO sector, one challenge that's one of the many challenges facing the sector, like many industries, there is a demographic time bomb. Aircraft technicians are not as attractive to the younger generation coming out of school or going into schools as it was 25 years ago. Populations are aging. There's not as many 25, 30-year-olds as there were 25 years ago. So industry needs to look at how to optimize and allow their technicians, allow the people that are working on the aircraft to be actually working on the aircraft and not dealing with the paperwork. So how to, not only is there the burden of the dealing with the paper records, there's all the burden that deals around interacting with the paper, creating the paper, reviewing the paper, making sure the paper is entered correctly from paper into systems. All of these manual interactions, which takes significant time away from actually keeping aircraft flying. The other part that comes into it is around the data, the quality of the data that's coming in. As long as the data is trapped on paper, it's very hard to do further operations with it. Where there's manual entry, there's data quality problems. So by moving things to electronic and digital forms, where the need for manual entry disappears, there is significant returns that can come to organizations that deal with it. And finally, as things move to a digital version, an awful lot of stuff then becomes candidates for increased automation, leveraging of data for either artificial intelligence or machine learning. There's just enormous potential and opportunity within the sector once we get this back to data. This is where it really makes sense. It's increasing the productivity of your workforce, cleaning up the data, and then allowing you to grow and leverage that data in many ways in the future. So that sort of wraps up where we are today. What we have coming up is at the end of August is a workshop here in Vienna. We'd like to thank you for participating on the call today. And certainly if there's any questions, Mark, if you could let us know. Also, if you have any further questions or want more information on the POC, please feel free to reach out to us at the email contact information there at office@ewings.aero. Mark, are there any questions?
Yeah, there's actually quite a few. I'm going to drop off your screen for a minute so people can watch us during the Q&A period, and then we'll put that screen back up at the end. But we actually have quite a few questions. I'm going to try to take them in the order that they came in. If you guys could just help us out by answering them, that'd be great. The first one is sort of a technical question. It says, is there any single element that gets a digital tag, and can you elaborate on tags?
Can you repeat the question, please?
Yeah, it says, is a single element get a digital tag, and can you elaborate on tags and how that sort of what a digital tag really means?
Yeah, a digital tag is I can show you something. Can I? Yeah, it's in form of a UHF RFID tag. So, thank you. I have it always in front of my computer. So this is such a digital tag. This is a UHF RFID tag. So there is nothing. So this is the blank inside of the tag, what I show you here right now. And this is in different sizes and forms available on the market. And then in the middle, maybe you see it, this black dot. You see it?
Yeah.
This is actually the chip, the IC, the integrated circuit.
Yeah.
And there all this magic happens with cryptography and embed this and use this technology to embed this tag within a blockchain environment.
And the tag that Stefan showed there is really more of an adhesive tag. They're obviously come in different form factors.
Yeah.
So that depending on the environment that the component is in, as to whether it's an adhesive-based tag or others, maybe an obvious statement. Just
because they need to last for 40 years plus those tags. So
okay.
The technology is there. It's used already in wide varieties. Even if we in the industry use it on the Airbus 350 or Boeing 787. So almost 2,000 to 3,000 parts per aircraft currently on those two types tagged with tags already.
Interesting. We have a little bit of a follow-up question here, and
Sure.
It has to do with access. It says, do different actors have the same level of access to the MRO blockchain?
Short answer is no. The whole thing about the blockchain is making the data sits on is now in the blockchain. The data is cryptographically secured, and the organization that puts the data out there owns the data and is allowed to grant access to other organizations. So no, it's not a one-size-fits-all. It's there is a permission-based system on it.
Correct.
Okay.
And the identity layer we build in helps to, with that. That's one thing. And then on the other side, it's cryptography, because you can then, in a granular way, allow what data related to a part, for example, the other one can see, or the MRO can see, because who owns the aircraft owns the data. And then, based on what the industry in future will agree in terms of how we share things, you can standardize this and program that in. But we can say it right now, because we are Ewings, we are so cool, we can just give an idea, you know, what we can do with this technology. But then the industry need to sit together, standard bodies need to sit together and say, okay, that's the way how we want to share. We know how it works from the technology part of point of view, but I'm sorry, we as Ewings, we cannot say, we can give an advice, and maybe it's getting heard from the industry, but we never ever can say that's the way how because otherwise we would be the police, and that doesn't work. So it needs to be governed together with the industry community. Okay.
So one sort of additional follow-on then that came in on the same line of thinking is that are there standardization efforts that are really underway? You've talked about a lot of different blockchains and some of the data exchanges. Are there standardization efforts that are on their way?
Yeah, there are groups working already together. So let's say SA is working, where we participate with on the G31 group, with a subgroup where some other colleagues are working with. On the EARC, that's happening. Then, of course, industry members themselves are trying proof of concepts together, either alone or with their supply chain. So on different versions using Ethereum, based on private or Hyperledger based systems. So things are ongoing. Standardization on those projects, you know, of course it's partly happening because technicians are building something, but are they building the right stuff? That only can be brought into into a way when other standard bodies who are existing, ATA, Spec 2000, and SAE are working here together, just to name two.
Okay, let's jump over to another train of thought here, and it has to do with MROs. There was a question that came in that said, in the example of an MRO, we have a system currently based on mountains of paper across, numerous organizations. How do we transition from paper-based, into a digital system? Is it envisioned that existing records would be digitized, or, how do you deal with some of the legacy, data that's out there?
It's a good question.
Yeah,
I think some organizations are dealing, probably some of the operators are people like EasyJet and Southwest are addressing it by scanning a lot of that paper into electronic form, whether it's turning into a PDF or some sort of an image, or running OCR recognition across the scan, may be varied. I think it's a transition. It is also a transition period of moving from A to B. I don't think it's not a great big switch that says, on Monday we flip the switch and everything flies over to digital. It's a journey that will bring it across. So that's where, I think that's the reality of it.
Yeah.
It would be a big switch. It would be a lie.
Yeah, and then the more people are using the new technology, the more it will get a commons than at the end of the day. So, but therefore it needs engagement. Therefore it needs us. Therefore it needs you. Therefore it needs the gentlemen and the people who are listening right now to this webinar, and just the right mindset to build it. Just make it.
Yeah, I try to let you guys answer all the questions, but I've seen 200 different aviation companies in my day, and there's a lot of them for different reasons that have digitized their records, for example. You know, there's a number of really good records companies out there, and I've seen massive efforts that people take paper records and digitize them, put them into systems for managing them, whether it be the airline or whether it be a leasing company. I've seen leasing companies take all the paper records for an aircraft transition when it's going back to another company and digitize them. And so, you know, there's a lot of different approaches, but it's all going to be based on the business case and the value and what are they really needed for. You know, that's my opinion.
Yep, I would agree.
Okay, great. Well, let me go to the next question. You know, given there are multiple stakeholders and they're required to be on the same page and they're required to adopt the same systems, who coordinates this? Who pays for the switch? I mean, how do you deal with, you know, how do you deal with the coordination and the different people and parties involved? I mean, what's your idea if you have like two different companies that are involved and data needs to be exchanged? How do you deal with that?
Well, this is it's actually a great question. This is the idea of a commons, so that all the records that are being kept are being kept because, not just because people want to keep them, but because they're required to keep them. So they're not. It's not really a competitive differentiator. So within the space, the sector, there's also interest across the different stakeholders to be able to share the information and share it in a much more cost-effective manner than they are able to do it right now. So the concept that we're looking at, and this is true for many of the blockchain world, is Ewings doesn't own this railway that Stefan, you know, the terminology is used. This becomes an industry-owned commons, so that it's not a case of any member within the MRO sector then worrying about Ewings pulling a fast one and doing, you know, all of a sudden jacking up the cost of operations in order to maintain this system. It becomes a industry segment owned piece of infrastructure.
Correct, and that's the reason why we're setting up a PUC on 30th of August 2019 in Vienna, Austria. Please come and visit us. It's a very nice country. We have very good wine and beer and Bratwürstel.
I've been to Vienna. It's a great place to visit. Yeah, it was really windy when I was there, though. So
you need to come again once. So we work together with, you know, with a diverse group of industry members at the end of the day. And to answer additionally the question is, it's a shared experience at the end of the day.
Yeah.
So share the costs in development as well.
Hey,
we put, you know, several years of investment onto our hat, and I think now it's time to share further our results and put money on the table and just make it together.
Excellent.
I think that's the.
Hey, there's a couple of more questions I want to try to squeeze in before we wrap it up here. So let me keep it moving here. The one question that came in was, how does somebody go about registering an asset?
Registering an asset works via applications sitting on top of, who are connected on the blockchain, or if you see it from the blockchain point of view, who are sitting on top of it. So that could be, you know, for who produces the part, a PLM system from call it Siemens or whatever, you know, the products were out there, who are used by the manufacturers, by the OEMs. Or if we talk about a certificate, you know, afterwards in the life cycle, who is produced by any MRO shop. So they can then use standardized data and a standardized way in terms of how we write it into the blockchain, or how we write what we previously explained, data into a metadata service and into the blockchain, and how we read it from them. So that also needs to be standardized. And that's the way connectors are needed to be built for all those ERP systems out there and PLM systems.
Okay. Next question is, has there been an analysis of how many blockchain transactions would be required, and is the proposed blockchain capable of handling, you know, the transaction rate that would, you know, be happening across the infrastructure?
So this question can only come from somebody who is dealing with it. We have done some analysis, but it's hard, to be honest, to say that. You can only make really, really estimates. So the thing is, in terms of what are you taking under consideration? What do you really, really put on the, want to have put on the blockchain? Do I want to really put each step, you know, within an organization dealing with, you know, with stuff on the chain, or is it just, you know, when that issue the certificate? So these are things what needs to become, so therefore I can't give you an answer. And in terms of input, yes, what we offer can handle it.
It would seem like with the scaling of any digital transformation technology that's happening and the rate at which things are scaling, that it would seem like the infrastructure and the capacity would be there to be able to handle that. I mean, think about the massive nature of the internet and of, you know, virtual computing that we have, and that's the whole idea, is scaling, you know, at this point. So it would seem like that would be a problem that would be solvable. Yeah,
and I think that's, you know, it comes back to, you know, the earlier question about, you know, what about all the legacy, and it's a big, this is a journey. You're right, and I think the implication, or the sort of the unsaid comment in the question is that, yeah, some of the existing blockchain technologies right now, they do have performance constraints. There's been significant improvement within the different technologies over the last 12 months. There will continue to be significant improvements. Where we are right now, where the industry is right now in our sort of digitization journey, I'd say we've got a few years yet before it's going to be fully digitalized, right? By the time everything gets there, I don't think performance is going to be an issue.
Okay. So we're still getting questions coming in. I'm going to jump to the next one if I could. So is there a use of blockchain that's really an effective solution to fake parts or the bogus parts industry?
Say again, please.
Is there really an effective blockchain use to the problem of fake parts or to bogus parts?
Absolutely, I would say. In that combination, we have explained it. Using a UHF RFID tag, having a secure identifier, where you know who produced this identifier. Only that company who has his credentials and is known by the others can produce such a tag. If I use a QR code, I just can copy and paste it if I want. With such a unique identifier, it's getting damn hard to fake it. Mm-hmm. You need to put some millions on the table to fake one tag in terms of starting probing the IC, chip that I showed you before, because there are 70 possibilities the way how you can get to the data on an IC. So one is probing, but as we have a distributed, decentralized PKI infrastructure afterwards with secure elements, it's getting really, really damn hard to put bogus parts there.
Interesting, very interesting.
And then in the combination with shipping information tied towards that, because some parts might not be able to be tagged. You know, like a turbine blade, I can't tag a turbine blade. So there you have a process in terms of, and now I'm really...
Well, the other part that brings it is that as you go across the chain of digital identity, so not only is the part, but then the manufacturer. So it's the cryptographic credential of the manufacturer as well that's tied into that identity of that part. So for the person to fake, so even if they could fake the tag, then they then have to be able to fake the identity of the issuing organization. Yeah. So you start to, it changes the landscape. Will I say it's impossible? No, I'm not sure I would say it's impossible. Will it be a lot more difficult? Yes.
Yeah, it really does change the landscape. I agree with that. It really does. Yeah.
Yeah. Definitely you need to dig deeper into the technology to understand that. So
anyways, yep.
Anyway,
another one?
Well, no, that's actually probably all the questions we have time for right now. We've exceeded our commitment on time. And so I wanted to ask if you guys would put your slide back up again, share your screen so people can see how to get in touch with you at this point. but you've talked about a proof of concept coming up here in August, and
yes. So we have already some signups there based on the people we're working together already. We are welcoming more on that. So please shoot an email if you want to dive deeper in another way. Just ask us. office@ewings.area is the way how you reach us best. So yeah, I say thank you from our side.
Thank you for your time today. Appreciate you taking an hour. One thing we all only have a limited amount of is time. So appreciate you investing the hour with us.
If people have additional questions, is it okay for them to reach out to you on that email address, office@ewings.aero?
Absolutely.
Definitely.
Okay, pay careful attention to the spelling. It's EWINGZ.aero. And Stefan and Michael would be happy to interact with you and answer questions. So again, Mark Schultz here with DigitalAircraft, and I wanted to thank you for participating in this webinar. It's really our goal here is to advance the cause of digital transformation in the industry. And so we're partnering with people with good ideas and good technology and thought leadership and trying to bring that to the community so that we can all as an industry move forward further and faster than we have in the past in the area of digital transformation. And so gentlemen, I want to thank you so much for your time and presenting your ideas and your concepts and your thought leadership. And we look forward to the great things that you're going to do going forward, and we'll be engaging with you in the future. Thanks, gentlemen, and have a great day.
You too, Mark. Thank you very much.
Thanks a lot.
Bye.
Thanks a lot for the audience as well.